Hey everyone, I'm Jennifer Hardwick and I'm a third year PhD student here at ICRA UWA. And over the last year or two, I've been working with the xGASS sample to investigate the link between specific angular momentum, mass, and atomic gas fraction. So this work is actually a follow-up work of my first PhD paper, which found that the angular momentum mass relation, or the Fall relation, had scatter, which was very strongly correlated with atomic gas fraction. So in order to investigate this further, we decided to look at the Obreschkow 2016 model, which developed a relationship between angular momentum, mass, and gas fraction using stability arguments, and came up with this Q stability parameter, which is related to angular momentum and mass, or J and M. So the O16 relation uses stability arguments to come up with this relationship here on the left, where you can see the model in the black thin line and our data is in the gray. So you can see that our data follows this model reasonably well. However, when we started to analyze it in depth, we found that it wasn't able to kind of perfectly represent our data. So if you could go to the next slide, we see that the discrepancy between our data and the O16 model is even more apparent in the top row there, where you can see the model in the shaded region and our data as the points. And you can see that our points don't follow the same trend as the model would predict, especially for low gas fractions. So what we did was we fit our own 3D plane with relationship between Jm and angular momentum, and found that a plane that had a weaker dependence on mass and half the dependence on gas fraction was preferred, which you can see in the bottom row there. So this has implications for theory of the O16 model, particularly the assumptions that went into it were probably too simplistic for our sample. And we hope that this work will be able to help influence how models are developed like this in the future. Thanks. So come have a chat with me about my poster if you like.